Now let's talk about monitoring adversarial robustness of machine learning models. While machine learning models these days are often quite accurate, the predictions resulting from these models are also known to be brittle. Okay? To illustrate, let us consider this classic example where there is the image of this piglet, which the model is classifying rightly with very high accuracy as pig, right? Now, if we add some imperceptible noise to this image and generate a new image, which to a human eye looks exactly the same as the original image, you see that the model's prediction has drastically changed, and now the label being given to this point is of airliner class with a very high confidence, right? So this has been a popular phenomena that has been observed in several works. That is, if you add a small amount of noise that is almost imperceptible to the human naked eye, the resulting images often get tagged or labeled as a different class with high confidence, right? So this demonstrates that these predictions are actually very, very brittle. So now how do we think about this in the context of model monitoring, and how do we actually measure the brittleness of the models is something that we'll talk about now. Okay? In order to measure the brittleness of the models, what we can do is compute the expected worst case loss for the model. Okay, so how do we compute that? What do I mean by that? The expression that you see here is basically computing the perturbation delta of a given point x for which the loss of the model turns out to be the worst, okay, with respect to that point x. So now if we can compute this with respect to all the points in the data distribution and then take the expected worst case loss. So this is the worst case loss for one point x. If we basically compute this for all the points in the data distribution and then take the expected worst case loss across the data distribution, then that provides us with a measure of the brittleness of the model, right? So in some sense, higher the loss, more brittle the model is, and therefore less adversarially robust the model is, okay? So the thing that we want to compute here to measure the brittleness or the adversarial robustness of the model is the expected worst case loss of the model, okay? Now, it is also important to continuously monitor this adversarial robustness of models on any newly encountered data. Why is this important? This is important because while the model might be adversarially robust in those parts of the feature space which are already encountered during the training process, this may not be true for other parts of the feature space which may be encountered only at test time when there is a shift in the data, right? So that's why it's important to compute this expected worst case loss of the model continuously so that we can ensure that no matter what data is coming in, the model still remains adversarially robust.